So I made it a bit.ly address so you could check it on your own. But I do want to hit 2 highlighted points here. So if you go ahead and I just put it on there so it's easy for you to do check. I do want to explain 2 of the bigger questions you guys have. So type this bit.ly address in. It's just a Google Doc. Great. DRQ. 2, great. All right, so before you get looking in deep those details, 2 things. Whenever you're specifying the force of attraction that's London dispersion based, you do. Here, I'll scroll back up because you guys are still working on that bit.ly address. You do have to look at number of electrons, right? So if they're nonpolar, you have to first look at number of electrons because it's all about polarizability. That is your main argument, or very important term that you should be using with any London dispersion discussion, not mass. So you'll notice, I think it was A or B on that first one. You see in red text, it says you did not get points for referencing mass. What was that, A or B? On like 1985. Sorry, 1995, the second one. You see the red text. There's only like 1 bit of red text. Okay. So basically, you have to reference electrons creating a more polarizable cloud. More polarizable cloud means that it can create a temporary dipole moment a little bit more readily. And that would be how you would describe it having stronger London dispersion forces. 2, the second thing I want to reference before you get in there, is the phase diagram, and it's the part that we just didn't get to yesterday. If you're looking at density differences, there's a really good explanation on whatever that, the unknown number 5, whichever the one asked about argon. If you have a positive slope between the solid and liquid phase, like this is slightly positive slope, then it's indicating to you that as you increase pressure, right, so going up the y-axis, you're going to then go from liquid into solid phase, which is indicating to you that as you compress the system under high pressure, it will increase the density and turn solid versus liquid. So it's indicating to you the solid is more dense than the liquid. And that is actually most things in life. Like most things, solids are greater in density than their liquid form. The one thing that's not is what? Water, because we know that ice floats. That's just a natural occurrence that we've seen every day. So you can then assume that the solid liquid line is not a positive slope, it's a negative slope. It's kind of weird and ugly, but it kind of looks like that. So it's a slightly negative slope. It's not always harsh. It's kind of like straight up and down. But that indicates to you that as you increase pressure, you go from, let me make that really harsh so you guys can see the difference here. That's going to go from solid phase, increasing the pressure, it then goes into the liquid area, which indicates to you that as you increase pressure, it's then going to not get more dense, it's going to get less dense and turn into, or sorry, it's going to get more dense, but its liquid phase is the more dense version versus the solid. So negative slope is going to indicate to you that the liquid phase is more dense than the solid. So that's kind of your cheat sheet there, okay? I think those were your major questions. If you have any more, look through there and I'll come over to you. And then go back to multiple choice for a couple minutes while you're still looking over at our keyboard. Specifically, do you star questions? Do you put question marks? Check those first. Your big questions. One of my YouTube channels or videos were not uploaded last week because it was copyrighted because I was playing music during the video. And it was like an old like 80s song, and it was like copyright violation, blah blah blah. So like, are you freaking serious? So I had to figure out how to like cut the audio from certain parts of the video so that's like.